Greetings, statistics scholars, and welcome to this, the third in our series of videos on Chapter 1. In this video, we'll be taking a look at observational studies and experiments, which are the focus of Section 1.3. Let's begin with some important definitions. Sometimes when a researcher is doing a study, they simply examine the cases in their sample and collect data from them, without making any attempts to manipulate those cases at all. Whenever they do this, we call those kinds of studies observational studies. Here's an example of one such observational study. Suppose a biologist has some humane traps set in the wild, and they catch a total of 116 rabbits, and they weigh them to investigate typical rabbit size. We would say that this is an observational study. The researcher hasn't made any attempts to manipulate the rabbits at all. They're simply catching them and weighing them and releasing them. Now, in other cases, we have a situation where the researcher actively controls one or more of the explanatory variables in the study. Whenever that happens, we call those kinds of studies experiments. Take, for example, this situation. Suppose that a biologist has 50 laboratory rats, and they randomly choose 25 of those rats to receive 100 milligrams of a certain drug before those rats do a timed run through a maze. The other 25 rats receive none of the drug before the maze run. In this case, we would refer to this study as an experiment. The researcher has actively controlled or manipulated one of the explanatory variables, which is the amount of the drug in the rat's system. Some of the rats received none of the drug, and some of the rats received 100 milligrams. And the researcher determined that. So because of this, we would call it an experiment. Now, with those definitions in mind, we're going to take a look at four different scenarios here, two from an external book and two from your textbook, to explore the differences between observational studies and experiments. First, we're going to take a look here at the first of two examples that come from a book that is called the Handbook of Small Datasets. This is dataset number 89, and you can see that the researcher has recorded the prices in pence of a 100-gram pack of a particular brand of instant coffee at 15 different shops in the village of Milton Keynes on the same day back in 1981. You can see that at one of the shops the price was 100 pence, at another shop the price was 109, at a third shop the price was 101, and so on and so forth. Now, in this case here, we first might ask, well, what is the variable of interest? The variable of interest here is the price of instant coffee in pence. It is a quantitative variable. Is this an example of an experiment or an observational study? If you said an observational study, you were right. The researcher didn't make any attempt at all to manipulate the cases. The cases here are the different shops, the 15 different shops from which the price of the coffee was recorded. And the researcher hasn't made any attempt to make any kind of manipulation or changes to things about those shops. They've simply gone into them and observed what the coffee prices were and recorded them. This is an observational study. Here's another example now, also from the Handbook of Small Datasets. Here you can see we've got data that come from an experiment to study the effects of different amounts of water on the germination of seeds. For each amount of water, 4 identical boxes were sown with 100 seeds each, and the number of seeds that germinate after 2 weeks was recorded. And the experiment was repeated with the boxes covered to slow evaporation. Altogether, there were 6 different levels of watering, coded 1 through 6, with the higher codes corresponding to more water. So let's ask some questions about this. First, let's ask, is this an observational study or a designed experiment? Well, that was kind of given away a little bit from the language given to introduce the data, but we definitely would say that this is an experiment. Why is it an experiment? Well, we can find that out by thinking about the variables here. What are the explanatory variables? Well, first, one of the explanatory variables is the level of water that the box received. And we note that that was deliberately manipulated or controlled by the researcher. Some of the boxes received water level 1. Some received a slightly higher level, water level 2. Some received water level 3, and so on and so forth. And the researcher controlled how much water was received by each box. They also controlled something else. They controlled whether or not the box was covered. In some cases, the box was covered. In some cases, it was not, to see how evaporation may have had an effect on things. But again, this was something that the researcher controlled. So because the researcher is manipulating or controlling how much water and whether or not the box was covered, we'll refer to this definitely as an experiment. We might ask as we close out this slide, what was the response variable here? Take a minute and think about that. What would you say is the response variable for this particular experiment? If you said that the response variable was the number of seeds that had germinated after 2 weeks' time, you would be correct. Now let's take a look at several additional examples that come from your textbook. We'd like to take a look at a sequence of 3 exercises from our WileyPLUS textbook here. The first one we're going to take a look at is exercise number 91 in section 1.3. It says that a recent article claims that green spaces make kids smarter. The study described in the article involved 2,623 school children in Barcelona. They measured the amount of greenery around the children's schools, and then they also measured the children's working memories and attention spans. They found that the children who had more vegetation around their schools did better on memory and attention tests. Let's take a look at the questions that are asked about this. The first question that's asked by your textbook is, what are the cases in this study? The cases are the 2,623 Barcelona school children. They're the ones that we're recording the data about. Questions B and C ask, what are the explanatory variables and the response variables? The explanatory variable here is the amount of greenery that was near a child's school. And the response variables are the measures of the children's working memory and the measures of their attention spans as shown on the tests that they took. Part D asks, does the headline, "Green spaces make kids smarter," imply causation? The answer to that is yes. The headline makes use of the word make. That word make implies a causation. E says, is the study an experiment or an observational study? Which would you say? The answer here for E is that it is an observational study. It is an observational study because the researchers didn't do anything to change the amount of greenery around the kids' schools. They simply observed what it was and then observed how well the children did on those tests. Question F asks, is it appropriate to conclude causation in this case? The answer to that is no. A very important principle from section 1.3 is that when a person does an observational study, making causal conclusions between explanatory variables and response variables is never appropriate. It's only appropriate to make a conclusion of causality in a very well-designed experiment. So whenever we see that we have an observational study such as this, we want to say no, that we cannot conclude causation. So therefore, the headline in the article was misleading. The headline implied there was causation between green space and the children's memory, but it is not appropriate to make such a conclusion of causation. Now, there is an association between the two. Higher vegetation was associated with higher memory and higher attention. Part G asks us to suggest a potential confounding variable and why it meets the requirements of a confounding variable. Here in this case, we might say that the income level of the neighborhoods that the children come from, the income level of the families, might be a confounding variable. As income level goes up for a neighborhood, there's probably going to be a little bit more green space in that neighborhood. And there's also probably going to be better results in the tests that the children take. So, in other words, we can't necessarily conclude that it was the green space that made the kids smarter. There might be another lurking or confounding variable, like the income level of the children's family, that could explain the association between those things. Now let's take a look at problem number 96 from your textbook. Problem 96 says a recent headline reads Early Language Skills Reduce Preschool Tantrum Study Finds. And the article offers a potential explanation. Verbalizing their frustrations may help little ones cope. The article refers to a study that recorded the language skill level and the number of tantrums of a sample of preschoolers. They ask us first here, part A, is this an example of an observational study or a randomized experiment? As an answer to that, we would clearly say that this must have been an observational study. They observed the language skills of the preschoolers and they observed their number of tantrums. Why would it not be an experiment? Well, there's no indication that they made efforts to manipulate or change the language skills of the preschoolers. They simply were noting how proficient they were in using language. B asks then, is it possible to conclude that early language skill reduce preschool tantrums? And the answer to that is no. Once again, this is a statement that implies causality. To say that the language skills reduce tantrums implies that there's a causal connection. However, we've just said that this was an observational study. Because it wasn't a designed experiment, we should never make a causality conclusion. What do we think might be a potential confounding variable here? You might say that the age of the preschooler is a potential confounding variable here. It might not be at all that the language skills are what are causing the lower number of tantrums. It could simply be that as the children are aging, that they are number one, improving their language skills, and number two, also reducing their number of tantrums. So the age of the preschooler may be the thing that's ultimately driving both of those things, driving the language level up and driving the number of tantrums down. As a final example, let's look at problem number 102 from your text. Be sure to get your beauty sleep. New research supports the idea that people who get a good night's sleep look more attractive. In the study, 23 subjects aged 18 through 31 were photographed twice, once after a good night's sleep and once after having been kept awake for 31 hours. The hair, the makeup, the clothing, and the lighting were the same for both photographs. Observers rated the photographs of these individuals for attractiveness, and the average rating under the two different conditions was compared. The researchers reported in the British Medical Journal, our findings show that sleep-deprived people appear less attractive compared with when they are well rested. We're going to answer the first two parts of this question, and I'll leave part C of this question to you as an exercise. Part A asks, what is the explanatory variable here, and what is the response variable? The explanatory variable is the amount of sleep that the subject received, and the response variable would be the attractiveness or the average attractiveness rating that their photographs were given. Part B asks, is this an experiment or an observational study? And if it is an experiment, is it an example of a randomized comparative design or a matched pairs design? Here we would say that this was definitely an experiment. There was an effort to manipulate or control the explanatory variable. In one case, for one photograph, the participants received a good night's sleep, but then they deliberately kept them awake for 31 hours, manipulating the amount of sleep before the other picture. Since sleep was controlled by the researcher, this was an experiment. Now, what type of experiment? As you read in section 1.3 in your book, you're going to read about two different types of experiments: randomized comparative design and matched pairs. In this particular case, we would say that this is a matched pairs design because with the two treatments, the good night's sleep and the sleep deprived situation, each one of the subjects received both of the treatments. Now, if we had had a situation where we had, say, maybe 12 subjects who were randomly chosen to be photographed with a good night's sleep, and then another 11 individuals who were photographed after having been kept awake, and if we randomly put the people in those two different groups, but each one of them had only one type of photograph taken, then we would call that a randomized comparative design, because different individuals, different cases were being randomly assigned to different groups. But in this case, each one of the subjects got both treatments. And we refer to this then as a matched pairs design. I hope you found this video to be instructive as we've reviewed concepts of variables, explanatory and response, and took a look at the difference between observational studies and designed experiments. A major takeaway from this section is that we want to be careful to classify our studies as one or the other. If we classify our study as an experiment, it may be possible for us to make some conclusions about causality relations between explanatory and response variables. But if we merely have an observational study, we need to be careful about writing some of the headlines that we saw in some of these problems that suggest that there is a causal relationship. We can never conclude a causal relationship between variables when we only have an observational study.